This Hangout's live on air. What is this, Lady Ada?
Wow, we're live on air here at the Adafruit factory. It's me, Lady Ada, here at Adafruit in downtown Manhattan, where we do all of the design, engineering, manufacturing, testing, shipping, the tutorials, the videos, the projects, the stuff that you love from Adafruit. It's all coming to you from here in the factory, and that's where we are. Me, Lady Ada, and of course, Mr. Lady Ada on camera control. But tonight is your time to shine. It's show and tell, which we do every week at 7:30 p.m. You will show off your project to us. Wow. We're going to be here till 7:55, so please take 3 minutes to show your project, or last 2 to 3 minutes, so you can get going as soon as possible and get to the next show. We're going to start off with Noe and Pedro.
Yay, hello everybody, happy Wednesday.
Happy Wednesday.
Yeah, so this week we put together a custom gamepad. So this is a gamepad that uses cherry mix switches, so it's very loud. For the brains of the project, we're using the Adafruit Feather 32.4 Bluefruit LE, and she's right there. And for the battery, I have a little 350 milliamp LiPo battery, and that's kind of it. It's the project. Oh, the closure is 3D printed, of course. The keycaps are 3D printed. And instead of kind of wiring everything together, I thought I'd make a simple PCB in EagleCAD, and I milled it on the other mill. And there's a lot of videos out on our Adafruit channel. So there's a video on that. There's a video on how to make the PCB in Eagle and how to design it in Fusion 360. And it's kind of fun and loud.
A lot of skills together.
Yeah, it's another one of those cool projects that kind of combined everything together. So very shiny.
Okay,
check that out. It's going to be up on YouTube at 10 p.m. ET, and the guide is up already if you guys want to check it out. And we talked about it on today's 3D Hangout show, which is a lot of fun. And we broke 200,000 subscribers. Thank you guys so much.
Yeah, we'll talk about that also on the show. All right, sweet. Okay, no small thanks to you. Big thanks to you. All that you did to make that possible.
Okay.
Thank you.
Scott.
Hello. I'm back with another top secret that I just got in the mail. Hi, Chris.
Hey, Chris.
This is the new circuit playground that I get to show off. I've been playing with it today. A couple things I did. One thing, since I'm playing with a bootloader, I actually set up a 2x5. I was talking about making wiring harnesses, and so I did a wiring harness so that when I use my J-Link, I can plug that in super easy. And then I've got MicroPython running on it. And in fact, I also got touch working. So if I touch the pads, I think these are them.
Ooh.
It goes around, and that's using the native touch support of the Atmel SAMD21. So that's the gist of it.
Fancy.
New toy.
Right. And do you want to announce what we're calling this very fun, easy, open source derivative of MicroPython? Do you want to be the one to tell the world?
Sure. So we were calling it Adafruit MicroPython, but we had some concerns that MicroPython, when you shorten it to MicroPython, you'd be confused with upstream MicroPython. So we've decided to call our variant CircuitPython, to go with Circuit Playground and all that stuff. It'll be MicroPython, but designed for beginners and to make it super easy to play with circuits.
All right. World premiere,
Dun,
announcements,
da, da.
and more. Thank you so much, Scott.
Yeah, thanks all.
Yay.
Okay. All right. Next up, Chris Young, welcome back to the show. Let's see if I can
Unmute
him here. Chris, you are on mute, and I cannot unmute you. Let's see what I can do here. Let's see.
Couldn't see.
Oh,
Yeah,
you're
now.
here.
Yeah.
Hello, Chris.
Hey, Chris.
Hey guys,
Hey.
greetings from room 207 of St. Vincent Specialty Hospital in Indianapolis. I want to tell you about my little adventure. I had to be rushed to the emergency room on December the 12th with some respiratory problems. And they had to intubate me, and then they put in a trach tube. And I couldn't communicate with the doctors and nurses. Most people would just write on a notepad or something, you know. but for me, I can't do that. So back on January 20th, on the show and tell, I showed off a little Bluetooth gadget that I built with Adafruit parts that lets me use my iPhone just by pushing a couple of buttons. And normally I just use it in my day-to-day life for playing with the phone. But when you're communicating with doctors and nurses, it becomes something more than that. It becomes a real life-saving tool. And so I dropped Phil and Lady Ada an email thanking them for making all these parts available and helped to save my life. And the outpouring of support for me has just been phenomenal. I just am so touched by the response of the maker community and all the well wishes. And I believe in prayers and good wishes and good vibes, and all sorts of spiritual support helps. And I've been getting a ton of it. And I just wanted to say thank you to everybody for the support. Apparently, I'm not yet ready to meet my maker. My maker still has some plans for me. He apparently wants me to do more projects and write more tutorials and share more open source. So you're not done with me yet. I'm still going to be around, and I have a lot more to contribute. And I just wanted to thank everybody for all the support and say a very Merry Christmas, a Happy Holidays. I'm looking forward to a great new year with all of you.
Thank you so much, Chris. You are one of the brightest lights in our maker community. Thank you so much for everything that you do and everything you share. Thank you.
It's my pleasure.
Okay.
Okay.
Merry Christmas, everyone.
All right.
Bye-bye.
I'll send you as many stickers as you want to, of course.
Okay.
All right.
Okay, get better soon. We'll see more cool projects from you.
That's right.
And we'll have more exciting new feathers and radios and Bluetooth modules. And maybe we'll do some more fun projects together in the next year to help people who want to do more accessibility stuff.
All right.
Wait.
Bye-bye.
All right. Fantastic. Next up, Daniel and crew, unmute your mic and show us your project. Hello.
Hey, folks.
Hi, first time here. I am a full-time engineer, but I do sneak away a couple times a week to teach middle school programming to my kids' school. These are my two kids. So I want to show off real quick a couple of circuit playground-based projects that we did with the class. So, that's a crystal ball. You guys see that?
Whoa.
All right.
That's cool.
Light sensitive sensor on the circuit playground. It's getting close. We made a quick little crystal ball. And then, Erica, we made a staff, a wizard staff. Because in the class they have a Lord of the Rings staff. So we made our own staff. And so with no buttons, just a circuit playground. So now,
Oh, that's so cool.
Nicely done.
I love it.
point it out, straight out, and turn red or yellow. So just with the accelerometer. So the kids had a lot of fun. They really, really loved it. And I've had a couple of kids even asked for it for Christmas.
Okay.
It's been a real hit.
Well, I really love those projects. It's a really great use of the sensors. I love both because I like how they have the lights, but you have to do something. You have to interact with it, because that's the really powerful stuff about sensors is how can you make it so it matches your environment. You have to do something. You have to interact with it, because that's the really powerful stuff about sensors is how can you make it so it matches your environment. You have to do something. You have to interact with it. Because that's the really powerful stuff about sensors is how can you make it so it matches your environment. Something you have to interact with it. Okay.
I'm like that kid sounds just like you.
No, it's me. Okay, well, awesome. Thank you so much. We'll send you 2 stickers.
Yeah, email support@adafruit.com. If you want that guy, that engineer guy to have one too, you can get 3, but
If he contributed at all.
All right, thank you.
It's up to the future engineers to decide. All right. Well, thank you so
thank
much.
Both.
Okay. Next up, I hope I pronounced this right. Shay or Shy?
Shy.
unmute your mic and show us your project.
So everybody, I'm Shai, and this is my son.
Kevin.
Hey,
And
Kevin.
so our project was for my wife's birthday last week, and we decided to make a lithopane. I don't know if you guys can see it, but we basically made 3D printed lithopanes around the outside of the family pictures. And Kevin drew one of the pictures in here. And on the inside, we have some NeoPixel LEDs. I'll have to turn it off, but they're in there on the 4 corners. And then we used a blue fruit feather BLE at the bottom underneath to communicate with the NeoPixel app, which you can then change the lights from. And so I designed all this in Onshape, and I'll make the files available. But everything was done from scratch. And then with the help of I think Rick on the forums, we were able to use the NeoPixel app.
And what does the text say on the front?
We love you, happy birthday.
Oh, see?
And that's in glow-in-the-dark PLA. So it's about 6 pieces with the top and bottom, and then the sides, and then you have these top covers that we put on top that were done in dual colors to help reflect the light. Yeah, go ahead.
So, like, you draw like pictures, and then there's this app that you just take a picture. But it's pretty hard just to get like one picture to work, especially when it's really small. And then if like you're getting bored of some of the pictures, then you can just change them out and put brand new pictures in. And you can see brand new pictures.
So all the pictures slide out, and then we can swap them out later.
Yeah, it's like a lamp that lights up the photos for you.
Yep.
I love it.
Colors. And then that's the inside on the bottom. I don't know how easy it is to see in there.
Yeah. Cool.
It's got a LiPo battery too, so it's portable.
Outstanding. Well, you get as many stickers as you want because it's someone's birthday. And I like the idea of now calling it Internet of I Love You Things. People have been looking for a new name, and I think you just found a really good one. So email support@adafruit.com, and we'll send you some as seen on the show and tell stickers. And thanks for making something to show how good this stuff can be used for.
Yeah.
Thank you. All right.
Thanks, Kevin.
Next up, Orlando, unmute your mic and show us your project.
Cool. So I worked on this a while ago. I worked on a bionic arm. So I'm using my EMG. So EMG is the electrical activity when your muscles move. So I'm using the electrical activity of my muscles to use as a PowerPoint presenter. And so I did this because the students I TA for, they were working on an EMG project for one of their classes. So basically, I had to do something too to kind of inspire them a bit. But yeah, their products were way better than mine, so they were way more inspired. So I was pretty useless to them in that context. But just to show you how it works, I'm going to pull up a PowerPoint. It's going to want to go in presenter mode. I'm going to have to take it out of that. And I will show you it presenting. Sorry, I should have fixed the presenter mode beforehand.
The hardest part of the project is not to PowerPoint.
All right, presenter. All right, I'm on the PowerPoint. So I have it set up so that I won't get on the screen. So if I snap once, it'll move the PowerPoint forward. If I snap twice, it'll move the PowerPoint backwards. Can you guys see the presentation?
Yeah.
Yeah. Sweet. You guys see it moving?
That's so cool.
That's so cool. And if I go snap twice, it'll go backwards.
Okay.
Yeah, obviously could have just used 2 circuits or multiplex them, but I decided just to try to use 1 circuit and to save space. So yeah, that's what I did, and I'm writing it up for the Learn system at the moment. So yeah, it takes some time.
At the end of that presentation, people say what a snappy presentation.
In some ways, yeah.
All right. Well, thank you so much, Orlando. Email adafruit.com, and we'll send you out an sticker. Thank you so much for putting it on the list.
Yes, sir. Thank you.
Okay, next up. If everyone can make sure they mute your mic, there's a little bit of echo. Next up, we're going to Richard. Hey, Richard.
Hey, guys. I know I haven't been in for a while, but I wanted to show off some of the Christmas presents that I've been doing. This is kind of my mini cloud. So the last time I think I showed off some of the ESP01 projects I did with the Christmas lights. This is a very similar piece of code and hardware that I'm using in it. It's just got 20 neopixels inside. The structure of the actual cloud itself looks like this. So it was all designed in Tinkercad and then using 123D to slice it up so I could assemble it with the laser cutter, and then put all the cotton around it so that give it kind of the structure. And then I have this tied into Adafruit IO, so if I send it a couple of different numbers, I can change the colors in here. And then I also have a couple of preset animations and colors that go together with different weather patterns. So it's using IFTTT to read Weather Underground. And if it's raining, it will do kind of like this effect with the sparkling blue. If it's snowing, which it has kind of done here the last few weeks, it goes to a sparkling white. And then it does kind of a sunshine effect when it's clear skies, and then kind of a pulsy white fog effect for if it's overcast. And then I have a couple of other triggers with sparkly rainbow color for New Year's Eve and for 4th of July. So I'm going to be giving 2 of these away to my fiance's family for Christmas, and hopefully it'll get used. But one other really quick thing I wanted to show is I've been working with machine access here at the space. Previously, I've shown off the NFC solution for that, but I recently got these things from Mouser. So this is for reading a chip card, and it just has all the breakouts so I can solder this to a board. It has all 8 pins that can connect to that, and then a tiny little switch at the end for when you insert the card to actually tell that a card's inserted. And I'm going to use the Hackaday tutorial on how to hack the Kinko's chip cards to actually make an Arduino shield with this. I haven't really found any place that has Arduino shields. I guess SparkFun used to have one, but they don't sell that anymore. And of course, everyone's using them for credit cards. So we'll use this to get machine access and to verify that people are using machines when they got certified and track time for that.
Super smart. Well, thank you so much, Richard, and thank you for sharing all those holiday gifts. That's very nice of you to make those things.
Yeah.
All right.
Okay.
Okay. Yep, we're going to keep speed round. If everyone keeps it a couple minutes, we get everybody in. Let's see.
Bren,
the dev. Unmute your mic and show us your project.
you're a penguin. Okay. Now we see
Video
you.
turning on.
Yep.
Hello.
See me?
Yep.
Okay. What I've got here is I've got this Raspberry Pi Zero powered, well, wrist-mounted computer. I think my video got off 1 second. This has a 5,600 milliamp battery inside of it, and you can see the desktop right there. I've got an Arduino Leonardo on the inside, and what that's doing is that's able to control. It's used for the control, so I've got up, down, left, right on the mouse, and then I've got left click, right click. I've also got a mode switch, which allows me to do escape and a bunch of other keys on here. I've also got a USB sound card in here, which allows me to do audio output through this headphone jack right here. And you can see that that's going to my headphones right here. And it's also got over here on the front of it, I've got a USB port and I've got a charger port, which is kind of hard to see because of the lighting. And then I've got my power switch right over here on the device. You can see that.
That's cool.
Inside the big giant battery.
Is that felt? Is it in a felt enclosure?
Yeah, I used a felt enclosure, and then the actual this little black rectangle right here, that is made out of PLA. It was printed. It was 3D printed.
Oh, super cool.
That's super futuristic.
All right.
I'm
Well, thank
digging
you so
it.
much, Ren. Email support@adafruit.com, and we'll send you a show and tell sticker. And if you can take any photos, send those too. We'll post it up on the blog.
Post it up on where?
The blog.
Adafruit blog.
No one says blog anymore. On our website. I'm old.
Okay, yeah.
All right. Okay. Next up, Zachary. Zachary, your mic and show us your project.
All right. You guys are almost out of time, so I'll try to make this fast. This is a Christmas present I made for the person who's my secret Santa. It's a AT Tiny 44 and 2 piezo buzzers and 4 very large, wonderful switches. And see if I can play it backwards. So it's like a Simon Says sort of thing. Yeah, anyways. What was really fun about this project is that I accidentally connected one of the programming lines to one of the piezo buzzers. And that spawned kind of a side project. So I made this little guy right here. I call it the AVR listener. And it hooks up to my USB Tiny ISP.
Good googly eyes action there.
Oh yeah, big googly eyes. Let me see if I can. I got to do a couple things with multiple hands here. So when I program a chip, you guys hear that sound?
Yeah.
Yeah.
Yeah. So the hissing is the data, and then right here, the last one was the fuse. So it's just kind of interesting. You can hear the difference between writing the chip and then reading the chip and then verifying the fuse.
That's cool. That's handy. So if you see like one of the LEDs isn't blinking, you know which line isn't working.
Yeah, so one is master out, slave in, one's master in, slave out, one's SCK, and it kind of works. And it's all driven by transistors. It's kind of the same circuit that's on the circuit playground, just duplicated 3 times. And I had a couple extra of these, big 9mm square piezoelectric elements, so I figured it was a good project. Maybe
we're all missing out with debugging because we see things. Maybe we should also be able to hear things.
Listening, by the way, the things you hear if you have like audio circuits and stuff, it can help a lot in figuring out what's wrong with your circuit because you can tell patterns so easily.
Everyone thinks the wire doesn't work because the inverter makes a high pitch squeal.
That's telling you it's working.
Yeah. All right. Well, thank you so much, Zachary. Email support@adafruit.com and we'll send you out a sticker.
I really like that.
Okay. We're going to go to Roberto and then see Scott. If you can keep it to a couple minutes, we could do this a while. There's a board. Okay.
Hi, everyone. This is a costume that I ended up wearing for Halloween. I had it on show and tell the last time, for Halloween. And you'll see the LR, God, I'm probably not going to remember, the 31 IS. And it's connected to the audio input to Pro Trinket. And what's different from the last time is that I actually have everything hooked up. And there are also 3D printed USS class ships right here that are attacking the board ship. And Phil, you actually gave me the idea to use the flowing EO wire as like the attack vector from like here to here.
Yep.
Here to here. And so if I cover this up, maybe you can see that it's actually flowing EO wire.
Yeah.
A little bit.
I was hoping that y'all would carry an EO wire board, but at this point,
we'll get to it. There's reasons.
Okay, and so until until I can switch off, I'm using the boards that are available. So the other thing is on this side of the board chip is just some of the stranded LEDs that are powered by a coin cell battery from y'all shop, and hinted here is like a EO wire tape. It's also from shop. And it goes around. I try to do like a Pokemon. And it's like.
Oh, this is great.
And then it has another little type thing. I actually wore this for Halloween to my buddy's neighborhood. And a few folks were like, hey, that's a board chip. I was like, hey, that's a board chip. This is the third and the fourth side. And it comes back around to the getting you remember the Enterprise class ships, that was my presentation today.
Outstanding. I'd wear that every day. And also, Locutus sends his regards. Thank you so much, Roberto. Of course, you get a sticker. You can put it on one of the portions where you shoot and it heals itself. Okay. All right. See, Scott, play us out.
Hey, guys. I'll be real quick here. I kept forgetting to mention this, but 2 weeks ago, we lost Greg Lake, who is one of the founders of King Crimson, Lake and Palmer. And I have to say that it wasn't music that they and like Carlos and Larry Fastened back. I probably would have been designing for Walmart instead of this. So I have to pay my respects to the founders of my inspiration. Now, next is a public service announcement. The wife of Ray Wilson, who lost this summer, said that the doctors attributed the origins of his cancer to his working with solder without a fume hood and handling lead without gloves.
Yep.
Also using Roundup in the yard and whatever. But the caution here is, you know, be safe, use gloves, use a fume extractor, live longer. Limor might know this, but Roland has reissued the TB303. It is now the TB03. It is one of the several items that they've, vintage items that they've re-released. Some are modules, some are desktop devices, like the Roland TR8. It's their TR707 drum machine and TR808 drum machine smashed into one, and it's a really nice device. And finally, I got the little string machine going. It's this little, now I've got the camera in the wrong place. Might be hard to see, but this module without a panel right here, you'll see the light turn on. That's a 4-note poly. It's using a 328p to generate 8 oscillators at a sample rate of like 31 kilohertz. It's not terrible. It's not great. It did make me redesign the module into this board that I will show you as soon as it shows me. Oh, why isn't it showing it to me? Anyway, I made a new version of the board that you plug a Feather and Zero into the back of because it has a much better CPU. And I will get that board in, build it up, try and code the thing to generate my waveforms with a much better output profile, because we're restricted to 8-bit PWM here, and with M0 I should be able to do 16-bit. Well, there's 10 bits on a DAC. I have a switch. I'm going to select, there's the DAC and there's a PWM module. I'm going to see which one sounds better. So, and I put a real carrier stripping filter on it. So more on that as I get it. But hope you got the boards I send you, and happy holidays, and see you next time.
All right. Thank you, everyone. Zach, John, Roberta, Amanda, John, Daniel, and Tam, Scott. Thank you so much. We're here every week, 7:30 p.m. And thank you, everyone, for sharing your hopes, dreams, projects, and more. It's important, as you can tell. This is bigger than just electronics. You can actually help your fellow human being. So thank you, and we're going to be doing Ask an Engineer in like 30 seconds.
Yeah.